To watch these important lessons, subscribe to DP Education's YouTube channel right now. Click on the bell icon to stay updated on the latest lessons. Sri Lanka's largest free online school, DP Education.
Right, children. Now we are going to start the next chapter of the lesson, that is radiation. Under this chapter, we are going to learn about the last method of transmission of heat. Now, do you remember what we learned so far during all the other chapters? In the beginning, we learned that when we consider heat and temperature, even though they sound the same, they are two different things. They are related, but they are two different things. And then we learned that expansion, liquid expansion, is the theory used to make thermometers. And then we learn about thermometers, we learn how to make a simple thermometer, and then we learn what are the scales of thermometers, and we learn that how to use thermometers correctly, right? And in the lab, and also how to use clinical thermometers correctly. So we learn about melting points and boiling point of substances, and also we learn what are the different methods of transmission of heat. Under those methods, first we learn about conduction. Now when it comes to conduction, we learn that conduction is the method of heat transferring through solids. There we learn that solid particles do not move, but from one particle to the other particle, heat transfers. So the second method of transferring of heat also we learn, that is known as convection, right? So when it comes to convection, heat transfers through liquids and gases by this method called convection. By forming convectional currents, heat transfers through liquids and gases. Right, children? So the last method of transferring heat is known as radiation. So when I was explaining this in the beginning, what is radiation, I briefly explained. So what is the method of heat transferring using radiation, children? I explained you all, even though when we consider about conduction and convection, particle involvement is there. When we consider the radiation, heat transfers from one place to another place without any involvement of particles. No solid, no liquid, or no gaseous particles. Okay, children? So we will go through this. The method of heat transfer without the participation of particles of a medium is known as radiation, which means with or without a medium, heat can transfer by this method. Okay, children? So heat travels from the sun to the earth by radiation. So when we consider the sun and the earth, right, if this is the sun and if this is the earth, in between the sun and the earth, space is present. Now space has no particles, right? Space has no particles. Even if there is no particles in the space, still heat travels from sun to the earth across the space. So this method of heat transmission from sun to the earth is radiation, right? There's no way to conduct or heat transmit through convection between sun and the earth because there's no medium. Okay, the only method left is radiation. Okay, children? So we feel warm when we are near a fire or a heated object. Now here, when we are near a fire, even if we do not touch a fire, or let's say that we have a hot kettle. This one's heat is very high. So even though we don't touch this, if we just bring our hand closer to this one, we can feel the heat of this. Right? We feel warm when we are near a fire or a heated object because heat travels towards our body by radiation. So we feel warmth of these objects, the heated objects, just because by radiation, heat transmits to our hand, right? All the heated objects radiate heat. Okay, children? So we feel warmth when we are near a fire or a heated object because, we'll underline, because heat travels towards our body by radiation, and any heated object radiates heat. Right, children? Okay, so conduction, particle involvement is there. Convection, particle involvement is there. Right? In radiation, no particle involvement. With or without a medium, heat transfers from one place to another place. Okay, children? So here, radiation near a fire, you can feel. Now, when it is in cold areas, sometimes we light a bonfire like this and we get our hands warm by holding our hands closer to a fire. Right, children? That is because due to the radiation, we can get our hands warmed up. Right, children? We'll move on to the next. To understand about radiation better, we are going to do this very interesting activity. The activity is finding out more about radiation. So what are the things we need? We need tin cans of the same size. And we need 3 similar thermometers, 3 cork stoppers, and we need white color paint, black color paint, cold water, and a stop clock. Right? We will write down 3 tin cans. They should be of the same size. Okay, similar tin cans, right? 3 thermometers. 3 thermometers. 3 cork stoppers. White paint. Black paint. Cold water. Stop clock. Three tin cans, similar tin cans, 3 similar thermometers, 3 cork stoppers, white paint, black paint, cold water, and stop clock. Okay, let's see how to do this activity. Look at the method. Look at the 3 apparatuses. You all can see the 3 tin cans, but their colors are different. We'll see what to do. Keep 1 tin can as it is. Now, what is the most of the time? The tin cans are silver in color. Silver, shiny surfaces. Okay. Keep 1 tin can as it is. This is that tin can, right? With its shining outer surface. Paint one of the other tin cans with black paint and the last one with white paint. Colored with black paint, colored with white paint. Okay, children? So, we will label these diagrams first. Thermometers. Right. Tin can with the shiny surface. Tin can with the black surface. Tin can with the white surface. So keep 1 tin can as it is with its shining outer surface. Paint one of the other tin cans with black paint and the last one with white paint. Okay? Add an equal volumes of cold water into each tin. Right? if you fill 50 milliliters of water into the first tin, the similar volumes of water should be filled in the other tins also. It should be the same. Okay, fix a thermometer to each tin can as shown in the figure and measure the initial temperature. Right? As we fill the same type of cold water, the initial temperatures of all 3 cans should be the same, children. Okay? So place all 3 cans in same place in the sun. So you have to take these tin cans outside where there is enough sunlight, and you have to keep it in the sun, right? Measure the temperature in every 5 minutes time and tabulate the readings. Every 5 minutes, for about 10 to 15 minutes, every 5 minutes, you have to measure the temperature of these tin cans, right? Initial temperature will be the same. Obviously, when you keep it in a place where sunlight is present, due to sunlight, these tin cans will get heated up, right? By doing this activity, we are going to check whether all 3 tin cans, now they are size-wise, they are similar, but color-wise, they are different, right? We are going to check whether all 3 tin cans are going to get heated up at the same rate. Okay, children? So we'll do this interesting activity now.
Right, children. Now we are going to do this activity to understand more about radiation. So I already explained you all how to do this activity. So look what I have here. I have 3 similar tins that I explained you all earlier. So here one is colored in black. So this one surface is colored in white. And this one we did not color, we leave it as it is. You all can see the surface is silver color and shiny. Okay. First of all, I am going to measure the initial temperature of water. Here I have a water beaker. I am going to measure the initial temperature of water. Right. You all can see very clearly the temperature is about 29 degrees Celsius, which means the initial temperature of water is 29 degrees Celsius. Okay. Now I am going to pour similar amounts of this water into these 3 tin cans. So using this small beaker, I am going to measure the water. We will take similar amounts. I am going to take about 150 milliliters each. Right. 150 milliliters of water. First I am going to pour it into this black color tin can. Then another 150 milliliters into the white color one. Then another 150 milliliters into the silver color tin can. Right. So as you all can see, we are at a place where there is plenty of sunlight. Now I am going to leave these 3 tin cans here in this place as it gets enough sunlight. And at the same time, I am going to cover the mouths of these tin cans with this lid. Right, children. Now I am going to check the temperature of all these 3 tin cans after 5 minutes. So using the stop clock, I am going to measure the time. Right, children. Now we have completed about 4 minutes. So when it is 5 minutes, we will stop this one, right? Right, children. Now 5 minutes gone. Now we are going to check the temperature of these 3 vessels of water, right? So the initial temperature, do you remember what the initial temperature was? It was 29 degrees Celsius, right? Let's check the black color tin can. Observe very carefully. Now the temperature is about 33 degrees Celsius. Okay, you also can note this down, right? 33 degrees Celsius, right? So we'll measure the temperature of the second tin can, which is a white color one. Now observe very carefully. What is the temperature now? Temperature is about 31 degrees Celsius. Initial temperature was 29 degrees Celsius, which means the initial temperature of the water was the same of all 3 tin cans. Okay. Now, after 5 minutes, the black color tin can's temperature is 33 degrees Celsius. White color tin can's water is 31 degrees Celsius. Now we are going to measure the temperature of the silver color can, which we did not color, with the shiny surface, right? Right, children. Observe carefully. What is the temperature now? It is about 30 degrees Celsius. If you observe carefully, you all can see the temperature is about 30 degrees Celsius. Okay. So the initial temperature of the water was of all 3 tin cans, because we transferred the water which was here to all 3 tin cans. So the initial temperature, now we transferred the water which was in this beaker to these 3 tin cans, okay? So the initial temperature of this water in this beaker was 29 degrees Celsius. So we can take as initial temperature 29 degrees Celsius. So after 5 minutes, we exposed it to sunlight, all these 3 tin cans. So after 5 minutes, this first can with the black color surface, its temperature was 33 degrees Celsius, right? This white color tin can's water was 31 degrees Celsius. And the silver color tin can's temperature was, what was the temperature, children? It was 30 degrees Celsius, which means the water in this black color tin can is heated up more than these 2 other tin cans. Now we are going to leave these 3 tin cans exposed to sunlight for another 5 minutes, okay? Which means after 10 minutes also we are going to observe the temperature. Right, let's start. Right, children. So we completed the 10 minutes now. So we will observe the temperatures again. Now earlier, 29, the initial temperature was 29 degrees Celsius. So when we observed after 5 minutes, we clearly observed that the temperature of the black color, the tin with the black color surface was the highest, right? And the temperature of water in the tin with this polished shiny surface was the lowest, okay? Right. Now we are going to measure the temperature of this water in the black color tin again. Observe very carefully. The temperature is at 37 degrees Celsius now. Temperature is at 37 degrees Celsius now. Right? I will dip the bulb of this thermometer in normal water. So to take it back to the initial temperature. And now I am going to immerse this thermometer in the second vessel, which means the vessel with the white color surface. Now you all can see the temperature is about 33 degrees Celsius, right? Earlier it was, when we inserted it to this black color tin can, it was 37 degrees Celsius. Now it is 33 degrees Celsius, right? Now I am going to measure the temperature of the water in this polished shiny surface, okay? Right, observe carefully. Now, if you observe carefully, you will see the temperature is at 32 degrees Celsius. Right, children? So, in the black one, 37 degrees Celsius. In the white color one, 33 degrees Celsius. And in the shiny surface, tin with the shiny surface, it is 32 degrees Celsius. So even earlier, even when we checked after 5 minutes, the highest temperature of water was observed in the tin with the black color surface. The lowest temperature was observed in the tin with the polished shiny surface. Now even after 10 minutes, it was very clear. The highest temperature of water was observed in the tin with the black color surface, and the lowest temperature was observed in the polished shiny surface. So in both the instances, the temperature of water, which was in this white color tin, it was in between the black and the shiny surface tin cans. So what is the reason for this, children? You all know that sun's heat reaches us as sun's radiation. So all these three setups get heated up because of the sun's radiation. So after doing this activity, it's very clear these black color surfaces absorb the sun's radiation faster than the other two. And when we compare all these three setups, the black color surfaces absorb sun's radiation faster. And when we consider the polished shiny surfaces, they get heated up because of radiation very slowly, which means polished shiny surfaces absorb radiated heat very slowly. Right, children? So you all observed what happened during the experiment. It was very clear that when we were doing the experiment, black color surfaces absorb radiated heat coming from the sun very fast. Okay, so do you remember what we did during the experiment? Right? So we took three similar tin cans. We colored one with black, the other one with white, and the other one we did not color. Right? And then we measure the initial temperature of water. We can do it in two ways. We can, before we pour it, like as I did it in the experiment, first I took the entire amount of water to a large beaker and I measured the initial temperature there, right? Using when the water was in the large beaker. So after measuring the temperature, I covered these three tins with water with lids and we exposed it to sunlight, and after 5 minutes and 10 minutes, we measured the temperatures. Okay, so it was very clear. So after doing this experiment, both the instances, after 5 minutes and 10 minutes both, it was very clear that the water which was in the black color tin, the temperature was the highest, right? The temperature of the water which was in the tin with the shiny surface was the lowest. The temperature of the tin with the white surface, it was in between the black one. It was lower than that of the black surface, the tin with the black surface, but higher than that of the last one. Okay, so after doing this activity, it was very clear that the black color surfaces absorb radiated heat really fast, and when we consider the polished shiny surfaces absorb radiated heat slowly. Okay, we'll write these things now. Right, so we have to include our readings in this table. The first column, time in minutes. 0, which means the beginning, after 5 minutes, after 10 minutes. Right, temperature of water in cans in degrees Celsius in 3 cans. So at 0, 0 means at the beginning temperature was 29 degrees Celsius. Here also 29. Here also 29. Right, after 5 minutes, do you remember the temperatures? Let's write. Here it was 33 degrees Celsius. Here it was 31. And here it was 30. This is the highest, this is the lowest. But the initial temperatures were the same. Okay. After 10 minutes, this one was, in the black can, water was 37 degrees Celsius. Here it was 33. And here it was 32. So after both the instances, after 5 minutes and 10 minutes, white can's temperature, right? It was always lower than that of the black can, but higher than that of the can with the shiny surface. Okay, so we'll write the conclusion. After doing this activity, it's very clear that black color surfaces absorb
radiated heat fast. Radiated heat, because these three tin cans got heated up because of the sunlight, sun's heat. It comes to the earth as radiation. Okay, so radiated heat fast. Polished, shining surfaces absorb radiated heat slowly. Right, children? Black color surfaces absorb radiated heat fast. Polished, shining surfaces absorb radiated heat slowly. Right? White color surfaces absorb radiated heat faster than the shining surfaces but slower than the black color surfaces. Okay, children? We'll move on to the next. So after some time, it can be observed that the temperature of the water in the black can has risen higher than that of both the other cans. This is the experiment we did. Right? Also, it can further be observed that the temperature of water in the can with the shining outer surface has risen very less. Temperature at the end of the entire time period, the temperature of the black color can is the highest, then the white color can. The temperature in the shining outer surface is the lowest. Okay, children? Water in the tin cans is heated by solar radiation, by absorbing solar heat. Now you know that sunlight comes to the earth as radiation, right? So tin cans get heated up by solar radiation, okay? It's clear that black color absorbs radiated heat very fast. Black color absorbs radiated heat very fast. That is why the water in the black color can gets heated up faster, more than the other two cans, right? And polished shining surfaces do so very slowly. What could be the reason, children? That is because these polished surfaces reflect light, right? The light comes to this one, part of this light is nicely gets reflected. Shiny polished surfaces easily reflects the sunlight. That's why, therefore, only part of it will get absorbed. Okay? White surfaces also absorb radiated heat less than black surfaces. Right, children? So even you can do this activity in different ways, children. So when you use these, you can use more number of tin cans. One can you can leave as it is. Another can you can color with matte black paint. The other can you can color with shiny black paint, and another one with white paint likewise. So you will realize, let's say that if you use two other cans, one is matte black, one is shiny black in color. The shiny black color tin can gets heated up a little slower than that of the matte black, because the shiny surfaces reflects light. Okay, so that is another way of doing it. So white surfaces also absorb radiated heat less than black surfaces, but more than the shiny surface. Okay, children, we'll move on to the next. So black surfaces lose heat very fast too. Not only absorbing heat, when you consider the black color surfaces, they absorb the radiated heat fast, and at the same time, they release the heat faster too. Right, children? Black surfaces lose heat very fast, while polished, shining surfaces do so very slowly. Right? If there are three heated objects, let's say that if there are three heated objects, you can use the same setup. When you do this activity, try to use the same setups. If this is the black can, if this is the white one, and if this is the shiny one, right? after the entire time, after heating them up the entire time. First of all, you have to heat them up to the same temperature, right? So number one, you have to fill them with the same amount of water and then fix the thermometers, and you have to heat all the water up to the same temperature, right? Let's say 50 degrees Celsius. And after that, you have to leave it, and you have to, but you should not leave it outside where there is sun. You have to leave it somewhere shady, because this time we are going to check how they release heat, right? Every 5 minutes you have to check the temperature. You will realize black color reduces its heat faster than that of the other two surfaces. Shiny surface releases its heat very slowly. Okay, children? So black surfaces lose heat very fast, right? While polished shining surfaces do so very slowly, right? Therefore, hot water in containers with polished shining surfaces can be kept hot for a long time. So countries like Sri Lanka gets more sunlight throughout the year because our country is located near the equator, somewhere closer to the equator. Therefore, it is more suitable to use light colors to paint outer walls of the buildings rather than dark colors. Why? When we paint it with dark colors like black color, the dark colors absorb more heat. Okay? Therefore, our houses will get heated up faster, which is very uncomfortable. Okay? So, right, walls of the buildings rather than dark colors. It's because light colors absorb radiated heat less, which prevents the interior of the house from heating. Okay, children, so this is the reason it's better to color the outer walls of our houses in light colors. Okay, children, we'll move on to the next. So we learned there are 3 methods of heat transfer: conduction, convection, and radiation. All 3 methods are given in this one picture. So heating water in a pan, in a vessel using a fire, right? So here, this metal vessel, this vessel is solid, therefore through solids, the vessel gets heated up by conduction, right? Even the part of this handle also get heated up by conduction, right? Conduction is the method where heat travels from particle to particle through solids, but particles do not move. When you consider this water inside this vessel, water gets heated up by convection. Okay, and when you consider this fire, if you bring your hand somewhere near this fire, you will feel the warmth. That is because of radiation. Okay, children, so I hope you understood the methods of heat transfer very clearly after learning these chapters and after doing all these experiments. Right, we'll move on to the next. So we have this other assignment. Find and report the outside color of the vehicle radiators. What is done by a vehicle radiator, children? Now you know, when you consider the vehicle engine, when you run the vehicle, the engine gets heated up faster, right? Due to fuel combustion, and because of when you run the vehicle gets heated up faster. But this heat produced by the engine is not good for the engine itself. Therefore, the engine should release its heat somehow. If the engine gets heated up excessively, it might damage the engine and also the vehicle. Okay, therefore, this excess heat should be released, right? So, radiator is another part fixed to the vehicle that can radiate this excess heat. So, how does this happen, children? Right? Find and report the outside color of the vehicle radiators. What do you think, children? If the radiator has to radiate or release heat, which type of substances, which colored surfaces can release heat faster? Now you know the black surfaces can release heat faster. Therefore, radiators are colored in, the outer surfaces are colored in black. Okay? discuss the reason for painting radiators in that color with your teacher. So I will explain very briefly. When you go to the upper grades, you are going to learn these things in detail. I will explain this very briefly, right? So if we consider this is the radiator, let's consider this is the radiator. Radiators have a specific coolant, right? Specific coolant that is important to cool down the engine. So if we consider this is the engine, fixed to the engine there are special chambers, special passages to send this coolant, right? So if this is the engine, fixed to this engine there are special passages. So this passage, one end of this passage is connected to this radiator, right? This is the radiator. Now it is colored in black, right? So from the other side, these passages are connected to the other side of the radiator, right? So this radiator, this coolant always circulates. This radiator releases this coolant from one side. So when this coolant goes through this engine, right? The heat is absorbed by the coolant rapidly, right? Heat is absorbed by the coolant rapidly. And then what happens, children? This coolant, this heated coolant comes from the other side back to the radiator. And it goes through the radiator. Because the radiator has a black color surface, it releases the heat faster. Again, from the other side, this coolant is sent back to the engine, right? So this circulates. So in order to release the excessive heat efficiently, radiators are colored in black, right, children? So we are going to watch a small video related to this incident. Right, children. So after watching that video, I hope you understood how the radiator function in order to release the excessive heat. Okay, children. So we have completed the entire lesson now. We are going to see the summary to see the topics that we have done so far. So the measurement of coldness or hotness of an object is known as temperature. Okay, it's a sensation. Heat is a type of energy. So after doing this lesson, now we know that heat and temperature are not the same thing. They are related, but they are different. Okay? Temperature of an object increases when heat is supplied. By absorbing heat, temperature of the object increases. Okay? And it decreases when heat is removed from the object. When the objects cool down, when the object releases heat, the temperature decreases, right? Thermometers are used to measure temperature. We learned how to use thermometers too. The property of expansion of a liquid is used in making liquid thermometers. So units of measuring temperature are degrees Celsius, degrees Fahrenheit and Kelvin. Out of these three, Kelvin is the SI unit. Okay, Kelvin is the international unit of measuring temperature. Clinical thermometer is used to measure body temperature. Right, children? The boiling point, 100 degrees Celsius, and the freezing point, 0 degrees Celsius of water are the fixed points of a liquid thermometer at 1 atm. Heat transfers by means of conduction, convection, and radiation. So we have completed the lesson now. So in the next chapter, we are going to do the exercise. So as usual, you all have to do all the exercise, answer all the questions all by yourselves before you watch the next chapter. And after that, you can watch the video and you can check whether you have written the answers correctly.
To watch these important lessons, subscribe to DP Education's YouTube channel right now. Click on the bell icon to stay updated on the latest lessons. Sri Lanka's largest free online school, DP Education.